So hello everyone, my name is Pritam and welcome to another video of the playlist data structures tree. This is the sixth video, and in this video we are going to discuss about the expression tree. Now what is expression tree? Expression tree means a tree by which we can express some algebraic expressions. Like an algebraic expression can be represented by a tree in which few nodes would be the operands and few nodes would be the operator. For example, minus a and b. So this is a tree, okay, and you can see minus is a operator and a and b are operands. So few nodes can be operator and few nodes can be operand. Now if I do the in order traversal, then a minus b would be getting. If I do the post order traversal, then ab minus and minus ab would be the pre-order traversal, correct? So you can see the expression we use in our mathematics is actually in order traversal of this tree, okay, nothing else. Non-leaf nodes are the operators and the leaf nodes are the operands. Yeah, non-leaf node like minus a and b. So here a and b are leaf nodes and minus is non-leaf node. That's it. Now if the operator is a binary operator, then the node will have two children. For example, plus a and b. If the operator is binary, obviously it would need two operands, so obviously two children would be there. But if the operator is a unary operator, then obviously, and every algebraic expression represents a unique tree. Okay, now let's take an example. In this example, we can see here is a minus, then plus, then divide. Here a, b, c, d, e, and here is an asterisk. Now how will we evaluate? Now for example, if let me do the in order traversal, then obviously what will happen? A, b. First of all, this is a left subtree, this is a right subtree. In order traversal, this will occur first, then this, then this. Then here if I do the in order traversal, then obviously this will occur first, then this and this. In this tree, then if I do the in order traversal, then obviously this one, then this one, then this one. That means a divided by b plus c minus d asterisk e. So this is the expression of the in order traversal, correct? This is the in order traversal. Now let me do the pre-order traversal. Now what will happen? Obviously this is going to happen first, then this one, then this one. Now here this is going to happen first, then this one, then this one, and here it is going to happen first, then this one, then this one, obviously. So what will happen? Minus, then plus, then divide, then a, b, c, and then asterisk, then d, then e. This is the pre-order traversal, okay. Now let's talk about the post-order traversal. In post-order traversal, obviously the left subtree would be occurring first, and then right, and then this, obviously. So here also a, b, divide, then c plus, then d, e asterisk, and then minus. So this is the post order, correct? So in this way we can like have a tree, okay, for various expressions. For example, if this is an expression, okay, I have written all these things so that the video length would be lesser, okay. So if this is the one, then obviously what will happen, that so a minus b asterisk c, we all know that b asterisk c would be occurring first due to the Bodmas rule. So that's why b asterisk c is here, then a minus b asterisk c, that is going to be divided by this entire thing, then here d plus e divided by f. So this is the thing which has been written here, okay. So if I talk about the pre-order traversal, this is the pre-order traversal, post-order traversal, this is the post-order traversal, in-order traversal, this is the in-order traversal. Now there is a catch. The catch is there is no parenthesis here. You can see no parenthesis. It should have parenthesis, isn't it? So that we could compute very easily. So to parenthesize, there is an algorithm, okay. Now if the node is a leaf node, okay, which is operand, then print the element of that node. So if the node is a non-leaf node, obviously print this, then traverse the left subtree, then print the contents of that node, then traverse the right subtree, and then print this one. So this is the algorithm by which you can parenthesize. We will talk about this later also when we will be doing the coding part, and we will be entering like some algebraic expressions like this, and with parentheses it will be coming out. Don't worry. Okay. Now the thing is, there is another way also, like to explain the things. Okay, we can easily construct an expressional tree using either the postfix expression or prefix expression. Okay, we have already seen the procedure of converting the infix expression and the infix expression to postfix or prefix to like infix to prefix and infix to postfix expression. Okay, like in the stack we have discussed. Okay, if you haven't watched that video, you have to go to the stack playlist and there you will have it. Okay, now let's see the procedure for the converting a postfix expression to an expressional tree. Okay, now how it is going to happen? Let's take a postfix expression. Okay, which is a b c asterisk, then minus def, then divide, plus, and divide. Okay, so the rule is, okay, when we will have like any variable or any operand, we will put it into the stack. Okay, so this is the stack. Here have in a b c, so obviously we will push a b c. Okay, so a b and c. Now when we will have any operand, okay, operator, sorry, then we will use like two elements from the top. Okay, where it is the top now, and we will compute it. Okay, so when we are having it, that means okay, so now the stack would be like this, and a would be here, and what will happen here? It would be asterisk b and c. Correct. Now the stack will go like this. Now what is coming, which is minus, then obviously again there would be a stack and there is only one element, and what will happen there? Okay, so there would be minus, there would be a, there would be asterisk, there would be b, and there would be c. So this is going to be the stack. Okay, now let's move to another one, which is def. So obviously the stack would be like this. Yeah, so the first one would be like this one, minus a, asterisk b and c. Okay, and then d, e, and f. Okay, now what will happen? Divide is there, then obviously this f and e would be involved. Okay, so here it would be d, and here it would be minus a, asterisk b and c, and here it would be, as it is a divide sign, then obviously divide would be there, e and f. Correct. Now after divide, what is there? There is a plus. Then plus means what? Plus means what? The stack would be like this part and this part would be involved. Okay, so let's see. The first part will be like minus a, asterisk b and c, and the second part would be like this part. Okay, this part plus d. Okay, So plus, then minus, then E, then F, and then D. Correct? Now there is a divide sign. Here there is a divide sign is remaining. So obviously there would be like this element and this element would be involved. Clear? That means there would be only one element in the stack which will contain, there is a divide and then plus, minus, E, then F, and then D, then minus, then A, then asterisk, then B, and then C. So in this way the expression tree is going to be made from the postfix expression using a stack. This is also an algorithm which will look into. Okay, this is going to be a thing. Like if you use any postfix expression by using the stack, okay, you can put those values into the stack, and when the variable would be coming up, you can compute those things and you can have the ultimate result. For example, if a b c d e f would having a value, then we would have an answer. Okay, a numeric answer, we can compute it. Like by default what we used to do, we used to have this kind of expression and we can find the value by Bodmash rule or by the operator precedence and associativity chart. Okay, but if you have this kind of expression, how will you do that? So this is the algorithm which I have discussed now. This is the algorithm by which you can easily find out the solution. Okay, this is the way I just like explain these things. When coding part will be done, then we can discuss all these things. So this is the like main thing which I wanted to discuss, and for that I need to discuss about the expression tree. So this is the expression tree and its application. So this is the ending part of the video, guys, and in the next video we will talk about binary search tree, which is a very important topic in your career. Okay, so this much for today, and please do hit the subscribe button if you are new to the channel, and share this video with your friends, and like hit the like button, and let me know in the comment section if any kind of doubt is there or any kind of suggestion, like how I could make it a better way to represent the things. And I'm trying my level best, and I hope you are liking it. Please hit the like button and let me know in the comment if you are liking it, and these comments will really motivates me like to make more videos for you guys. Okay, this much for today, and see you in the next video.